In this video, we are going to solve another problem for Turing machine for the language a raised to I b raised to j, where I is less than j. So we are having a raised to I. So first we are having a in our language, then we have b raised to j, that is we are having b's in our language, and it is given to us that number of I is less than number of j. So if we have value of I as 0, j can take minimum value as 1, 2, 3 and so on. If the value of I is 1, then value of j will be taken as 2, 3, 4 and so on. And similarly, if the value of I is 2, j can take values like 3, 4 and 5, so on. So based on this, the strings that could be generated from this language could be b, 2 times b, 3 times b, when we consider the value of I as 0. Similarly, if the value of I is 1, the string generated would be abb, a 3 times b, a 4 times b and so on. And if the value of I is 2, the values generated from the strings would be AABBB, AA 4 times B, AA 5 times B and so on. Now in order to construct Turing machine, initially let us consider that we do have A, right? So if we do have A, for this corresponding A, we can cancel this corresponding B, as we have done in case of palindrome or A raised to n, B raised to n kind of example. But now here we may have additional number of b's remaining in between, right? So if we keep on cancelling a's to b's, what will happen? For this a will cancel this b, for this a will cancel this b, and some more number of b's will be remaining inside, right? For this a will cancel this b, this a will cancel this b, some more number of b's. This more number of b's would be either one or many, correct? So either one or many, right? So if these b's are remaining, then we can take our diagram to accepting state, that is HA. Okay, so initially suppose we are in state Q0, we'll be processing first blank and we'll move to right. Okay, then we will make A as blank and we'll move to right. We'll make A as blank and we'll move to right. Then we'll keep all A's and B's as it is and we'll move to right. We'll keep all A's and B's as it is and we'll move to right until we find a blank. The moment we find a blank, we'll keep this blank as it is and we'll move to left. Once we come to left, we will be encountering a B. This B will make it as blank and we'll move to left. Once we come back from this, again we'll keep all A's as it is and B's as it is and we'll come to left until we find a blank. The moment we find a blank, again we'll try to move to right. So whatever number of A's are there, we'll try to balance all those A's with B's using this part of our diagram. So for this A blank, this B will be made as blank and we'll come and stop here in this example. Similarly, for this A, this B will be made blank and we'll come and stop here. For this A, this will be made blank, this A, this will be made blank and we'll come and stop here. In this example, for this A, this B will be made blank, for this A, this B will be made blank and we'll come and stop here, right? Now, wherever our tape head is present, we will be having one or more number of B's. One or more number of B's, and we are standing in state Q1. Similarly, if we don't have A altogether, in that case also we'll be standing in state Q1 and we have to process B, 1B or more number of B's. So from here our next part of a diagram will start where we have to construct a B star, right? So minimum 1B will be coming over here and this B I'll keep as it is and I'll move to right. This B I'll keep as it is and I'll move to right. I may have more number of B's also which are to be processed, so that we can process here and we'll move to right until we find a blank. The moment we find a blank, we can enter into accepting state, that is HA. So this becomes the solution for A raised to I, B raised to J, where I is less than J. All students are advised to write the 5 tuple for this particular Turing machine and solve one example, that is AA, BB, BB.